Here we have an assembly. It's got a brass core, steel shell. It's got a length of 4 inches. And I want to know how much load it's going to take to compress this thing 0.003 inches. Okay. Um, and that's all I want to do. I don't want to worry about this last question. We'll cross that one off right there. Okay. So, so here's what we'll do. Okay, so the first thing is, again, we want to cut our thing to determine the internal load. So when I do that, I get something like this, where I've got P pushing down. And then I've got basically two P's pushing back up. I've got the P in the steel on the shell, and then P of the brass in the core, right? And then those two things have to basically add up to equal the total P. Okay. However, I don't know very much at this point, right? Statics is only going to get me so far. I know the total P is the force in each of those members of the assembly. Okay, so I have to use something called a continuity equation, using what I know about the deformation going on here. And what I know is that those two things have to both compress the same amount, and they have to compress to 0.003 inches for my problem, right? So I know that the deflection of the steel has to equal the deflection of the brass, right? They have to have the same amount because of that cap that I have on there, and that has to equal 0.003 inches. Okay, and I know that delta equals PL over EA, right? So basically I know everything except for P in this situation, right? And I can do that for both steel and the brass. So starting with the steel, I say, okay, well, delta is 0.003, okay? I'll do the denominator first. E for steel is 30 times 10 to the 6th psi. A, now remember this one is kind of a shell, so it's going to be pi over 4 outer diameter squared minus inner diameter squared. So it's going to be 0.35 squared minus 0.28 squared, basically outer and inner on that, right? So that's the area of the steel. Okay, now I don't know the load. That's what I'm trying to find. The load of the steel is what I'm trying to determine, and the length is 4 inches, right? So from this, I can learn that the force in the steel has to be 779 pounds, okay, to get that steel to deflect 0.003 inches. Now, do the same thing for the brass core. Get 0.003. Okay, and the brass is 15 times 10 to the 6 for the modulus of elasticity. This guy is solid, so it's just pi over 4 times its diameter squared. Its load is what I'm trying to find. Force is the brass. It is also 4 inches long. So again, this guy has to deflect the same amount as the steel, which was 0.003 inches. And in order to get that to happen, I need to place 552 pounds on the brass. So from that, I learned that adding those two together, the total P to get that sort of a compression then becomes 1332 pounds. So again, the key to this is you start with statics, just like we do all problems in this course. Okay, but then I don't have enough equations from statics to do that, and then I start using these compatibility equations where I use what I know about the deflection of the material to figure it out.